Okay, let's talk about interest rates. First of all, let's go back and remind ourselves about compounding interest. If I invest P dollars at some R interest rate, I calculate my compounding N times per year. You may remember that the amount of money I have at time T, A of T, is P times 1 plus R over N to the power of NT. And I could compound daily, 365 times a year. I could compound weekly, monthly. I can compound whatever I want. But the way banks actually calculate interest generally is called continuous compounding. So instead of compounding at particular intervals, they just have a formula for continuous compounding. And what this means is that the interest added is added at a rate proportional to the amount in the account. Well, if that sounds familiar, the rate of change of money in your account is equal to some proportionality constant multiplied by the amount of money in your account. But our proportionality constant in this case is the rate of interest. So what this means is that the rate of change of your money with respect to time is equal to R times the amount you have present. And since you start with that much money, what we can do without redoing the whole process is go back and say that y, given that y is equal to an initial value times e to the kt, we can therefore write the amount you have at time t is equal to your initial investment times e to the rt. And this is continuous compounding. To me, the interesting part here is that we didn't force E into this problem. This is just how it came out, and it's one of the interesting properties about the number E. Now, let's talk a little bit about the other way to think of this. The other way to think of this problem is that if I have some amount of money in the bank, it is changing given our original equation, and I take the limit as n goes to infinity. Notice that this will tend to 0 and that this will tend to infinity. So what I'm really doing is I'm saying, well, what happens if I have a limit where my ultimate limit is 1 to the power of infinity times my initial amount, but what I actually get is my initial amount times e to the rt. So 1 plus r over n to the nt trends towards e to the rt as n goes to infinity. So this is a super simple way to do compounding interest, which is one of the reasons the banks do it. They don't have to constantly be calculating how much money do you have, how much interest should we give you. Why don't you go ahead, if you're in my classes working out of my book, go ahead and do exercise 19. And when we come back, we will have another example regarding radioactivity and radioactive substances. Thanks for watching.